Hi, everybody. How's everyone going? I'm super stoked to be here. As you probably know, we at Volvo Cars have for the past almost 100 years been trying to keep rust out of our cars. But given the upside down nature of the world these days, it's only fitting that now we have a new kind of rust in town, and this one is actually fantastic for cars. So I'm gonna go through that journey, how it looks so far. Yeah, like you said, I have a lot of material, so we're probably gonna have to take questions afterwards. But just come and find me one afterwards, so we can discuss. So there's this quote from Graydon that I really like. This is from the really early days of Rust, because it highlights that Rust actually doesn't bring that many like really novel things, although it does that as well. But it's mostly this curated, hand-picked, and well-curated package of functioning ideas and technologies in this very coherent package. And if I were to do like an automotive spin on that quote, it will be what happened to the clicker? Oh, here it is. Yeah, it will be the nemesis of our past. Given our past with Rust, comes to save us from our future. Yeah, but anyway, so yeah, I'm Julius. I'm the team lead for the low power processor team at Volvo Cars, and so we are, like Hugo said, we're the first ECU completely written in Rust in the automotive industry. I've been at Volvo since 2017, and now the obligatory disclaimer that all these ideas and opinions that I'll express today are my own and not Volvo's official position or anything. Yeah, like Hugo said, I've been doing this for quite a while now, and actually closing in on 25 years, and I've been doing a lot of programming languages. Okay, this doesn't work. I'll do it, I guess. But in my opinion, Rust is actually the biggest deal that is come to our shores during my career. And then I'm referring specifically to this foundational software that Nico was talking about. And yeah, so and you know, I don't say this lightly. I've actually tried basically everything there's out there, or mostly. So but let's start with start from the beginning. So this is what AI describes as an enthusiastic developer. So this could have been me back in 2015. I had just started a new project or at a new company, and I was super happy that I was really impressed with their engineering and their rigor and their like practices, and I was like, finally I'm at a place where I don't have to worry about these obscure memory issues and weird things. And spoiler alert, I was not free from those. I mean, I had to debug one of those just a few weeks later. So I had this visceral realization, like, what if this is as good as it gets? I mean, maybe it's not going to be any better. But a few weeks later, this came out, and I found it really intriguing. But I tried to get into it, but it didn't really click for me. It wasn't until 2 years later when I decided to really give it a shot, and I read both of those books cover to cover. And that's when it finally clicked, and I was really convinced that we actually had something here. So now I was back to this guy, and this is where I joined Volvo Cars. And back then they were actually looking at where the trends are going, and what areas are we seeing in terms of growth and things like that, and what kind of systems would be needed to solve that. And I also read from this, or maybe you spotted as well, that the automotive industry has tools to tackle these traditional functions, but it's all the other areas that are just exploding in complexity, and it's quite unlikely that the traditional tools will be optimal for that. So here is the SPA2 architecture that we came up with. It's going to be way too technical to go into that right now, so come and find me if you want more details. But when I started, and maybe the key piece is the core computer, which is new, and these integration units that convert communication onto these classical ECUs. But when I started, it looked more like this. So we had a glorified Raspberry Pi acting as a core computer, and we wanted to do some experiments on how that would work. So we wanted to be able to send commands from the Android UI to the core computer to perform certain things. And so we needed this vehicle HAL in Android to achieve that. And so I, naive as I was, I tried to write a vehicle HAL in Rust. And this was quite, it was a quite daunting project because there was a lot of, things to get to work. I mean, building it for Android was a whole obstacle in itself, and I had Futures, and I had Tokyo, really early versions of that, and all kinds of things. But then that was my first experience of this. If it compiles, it works. Because when I finally got it to build after a couple of weeks, and I ran it in the car, I could control the fans and the AC at first try, which was a huge proof point for me. So now we're up almost 2 years, and I gave my first Rust talk at Volvo Cars, and this is where I was able to I was basically telling them or trying to make the case that Rust could actually be a key differentiator for us as a company, and I was able to convince a few people that among a couple of managers, and I was also fortunate to meet a fellow developer that had similar ideas, and we kind of joined forces. And at the same time, the 2018 edition came out, which was really important for us. And I know it was really exhausting for the Rust community and the Rust project, but we're really thankful. And then now we come to 2019. Or 2019 rolled around, and we got the green light to actually try it out. So we started looking for where we could actually try it out, and we came to the conclusion that the low power processor would be an ideal target, and I'll come to that later. But that one would require no SSD, and bare metal programming had just become basically available through this 2018 edition. And also thankfully, things were picking up. So OxidizeConf was created that year, and we went there to learn more about embedded. And then we also commissioned our first Rust thesis to basically assess the viability of using no SSD for development. And then by the end of the year, we formed the team, so we were ready to get started. When looking for where we have or where we could run Rust, things weren't looking that good. I mean, everything Rust wasn't supported practically anywhere. So basically, it's only the core computer left. And if we open up the core computer, we see that it's actually built up of 5 different processors. But things didn't look much better there. It's basically only the security gateway that was running Linux that theoretically had support, but our software vendor didn't, and it was a whole thing. So what was left was the low power processor. And it actually happened to run the Cortex M4 architecture that was the best supported embedded architecture at the time. So that was quite helpful. So just a bit more details into the low power processor. It's always basically it's always powered on, so it needs to have low power consumption. It's supposed to power on the system given certain events, so it needs to be really robust, and it needs to power on when it's supposed to, and not when it's not supposed to. The hardware is constructed in a way that you can't turn anything off, and therefore there is no safety critical aspect of it, and so we didn't have to worry about that. And the functional scope itself was fairly limited, so we thought we could do it with a small team. And speaking of team, just a slight tangent on that. So we were 4 initially, but we scaled up to 4 to 6, and yeah. So but we were all like senior engineers, but with no Rust experience. But we have consistently found that we can basically train any experienced embedded engineer as long as they have this, curiosity mindset and a bit of humility and willingness to learn. But with the proper guidance, we've shown to make it work. But without the proper guidance, okay, that we ruined the joke there because it was supposed to be a GIF there. But anyway, it ends like this. So so yeah, working with the Rust compiler, it can actually feel like running into a wall sometimes. So we realized fairly early on that we needed to get external experts to help us, and we found this company in Sweden that was really good at that, and they helped us with the drivers and the bring up and all different Rust issues that came up. So that is something that we highly recommend for anyone doing the same. So this is what we ended up building. It's a Arctic application, 100% written in Rust, including the bootloaders and everything. And then we have this LP agent up running on the high performance computer written in C++ that basically abstracts the communication with the LP so that it can actually be accessed as any other service in the rest of the system. But we also realized fairly quickly that testing it on the core computer would be really hard because it has all these different connections and pins, and we want to be able to read and write and probe and prod everywhere. And doing that on the core computer, it's fairly tricky. So we tried to come up with a test unit that we could build ourselves. And this was our first try. This is the so-called PEEL processor in the loop, our first edition. But as you see, this became really, unmanageable within 5 units. And one wire falls off, and it's a nightmare to debug. So we consulted with the Rust experts who happen to know how to build hardware as well, and we came up with PEEL 2.0, where basically we have up in the right corner we have the LP circuit basically cloned from the core computer. And then we have a USB connection there on the left middle, and then through this USB connection we can basically access everything, all pins, all communication, and pretty much test everything. We can also do fault injection. We can turn off clocks and see what happens, and all kinds of things. And the nice thing also is that it stacks, so we can in our CI rigs we can actually have multiple of those, and so every patch that we create gets run through this whole battery of tests. And so we were ready to start releasing, and in 21 we had the first UDS server. UDS is the Universal Diagnostic Services protocol that it used in automotive, this meant that now we could start delivering our software using the standard flows to the rest of the car, and they could start, testing it out, filing bug reports and things like that. And then in end of 23, we reached 1.0, and this is where we had all the base tech and cybersecurity requirements in place, so that we could actually go for production signing. We didn't have everything in place otherwise, but to have this green light that we could go for production signing was important, because otherwise we are not allowed to send it to the car factory. And then the production release came about 6 months later, in March of 24, and so 3.5 years from literally zero to production. And here is the core computer, and here you can find the LP. Which brings us to the current day. Where are we now? well, we're basically finalizing the last features. We're going into some sort of maintenance mode, and we're also scouting for new opportunities. And if we just go through the results real quick, so we have the first Rust ECU in production. We've been between 6 and 10 developers during the whole process. We're up to around 170,000 lines of code. 90 of those are Rust, plus additional 70-ish crates. We designed our hardware, maintain our CI, and we had to write all of these things from scratch because that didn't exist. Even though the third-party ecosystem is amazing, those kind of things didn't exist at the time. And then if you come to the products or the quality side and the productivity side, if you remember from Lars Bergstrom's talk at Rust Nation last year, Google had done this huge survey on developers there, comparing it to C++, and they found twice the productivity. Teams had higher confidence in their correct, that the code was actually correct. We had code reviews were easier, and each individual contributor was, more confident in their own contribution. And so if we try to, since we don't have this vast collection of teams using Rust, we only have one team. So basically, we can only try to compare our own results. And on the productivity side, we actually see that we are easily twice as productive as our comparable teams, and even up to 4 times, depending on, because even though our ECU is not doing the same as anyone else, it's not an apples to apples comparison. We still have this chunk of requirements that everyone needs to fulfill, and to be able to measure that and see how fast we were able to do it compared to the others. We reach these numbers. And then for the other factors, we don't really have anything to compare with except for our own our own experience. But and we have around 100 years of combined experience in the team, and we basically all thumbs up on that. And just to give you some sort of proof, so this is the chart that shows all our fault reports that we have during the project, and as you see, it's a grand total of 18 fault reports that we had during the total during these 3.5 years, and that's if you divide that out, that's like one developer doing one bug every other year, or 0.2 bugs per 1,000 lines of code, and that's around 100 times less than you see in other similar projects. So our conclusion there is that that Rust is really at the heart of this what you say, need for improvement. So we have this great tool chain from the community and crates that empowers us to do better work that we can take pride in, and that kind of feeds this vicious cycle. Would you say I'm overselling it? Things are not perfect. There are issues as well, and here are the same that you've probably seen a million times, but at the same time, the positives vastly outweigh the negatives. So final verdict on the project so far. Well, I can't say anything else than it was a huge success, since we've outperformed all the other teams on basically any metric. But at the same time, I can't say that we have won and we are just rolling out Rust everywhere. There are still a lot of proof points to be done, and even if those, or even when we've done that, there's still no guarantee that we will succeed. So we need to be the change that we want to see in the automotive industry. So all my fellow automotive players, I encourage you to try it out. and start using it. And that brings us to the future outlook. I'm almost done. How does Rust support look today compared to back then? Well, now everything has opened up, basically. There are a few holdouts here and there, some obscure architectures that don't support it, but now the fields have opened up. And similarly, if we look at the different software stacks that we use in the car, we already have some Rust coming in the Android system and our own stuff, but everything else is actually ready to use Rust. So the options are quite promising. But now I've been rambling a lot about automotive, and I haven't come into safety critical aspect of it. And Rust is definitely like a great fit for safety critical, but that's going to take time. And but at the same time, in the last couple of years, things have been picking up really fast. And last fall at RustConf, the Rust Foundation started the Safety Critical Consortium. We have the Ferrocene compiler and High Tech coming out with safety qualified compilers. We have the specification from Ferrocene that is now being donated to the Rust project. So now we have an official specification ongoing, and we have a lot of things in the works, like closing the final gaps before we can say that we are like fully safety qualified. So my guess is that 2026 will probably be a good year for safety critical in cars, and that's because Rust has this unique potential in the safety critical space, in my opinion. For example, here we have 2 talks from RustConf last year where they are showing that I highly recommend that you take a look at, because they're showing how you can actually use the type system to actually achieve basically statically or at compile time to ensure that you have behavior that you otherwise need to have runtime verification on. And I think for safety certification that this can be a game changer. So we can actually try. Rust is famous for finding this third path in you can have safety and speed and not just one of them. Here we can. I think we can also find the third path in safety critical. So this correct by construction is becoming true for more and more cases, and I think we can even reach something like this, like that it's actually compliant by construction. That of course that will not apply for absolutely everything, but there are probably things where you can actually make sure that I'm almost done, that you can ensure that that you can't construct them any other way than in a compliant way, so to say. And of course, this is important because money, of course, always decides. 90%, I don't know if you know this, but for these higher ASIL levels, 90% of the development effort is spent on verification. And the car industry spends 2% of its revenue on warranty costs every year. So any dent that we can make in this, and I mean, looking at the numbers that we've seen today, it's billions, literally billions in savings that we can achieve. And I just want to end on this final note on this interesting duality between safety and security. We make this distinction in the automotive industry that on one hand you have things that are safe to use, and safety that the product is actually safe to use, and then security that it's actually safe from hacking. And we have these different processes of ensuring both of them, and they, on a really high level, they look pretty much like this. I hope the security and safety experts are not going to hang me because it's super simplified, but as you see, it's mirroring each other. You do the hazard analysis and risk assessment or you do the threat analysis, and then you define your safety goals, and you come up with a safety case, and everything is, and then you develop the code in this extremely rigorous manner. So everything like mirrors each other until you reach the final step, because on the safety side, once you actually certify it, it's practically set in stone. You don't want to touch it because you need to recertify, and that's going to take a lot of time. While on the other hand, with the security stuff, you really need to keep that up to date all the time, and these are like fundamentally at odds. So so I really think that Rust can be a solution here, because on the one hand, you don't have the same amount of bugs and other things in the first place, so that you don't need to be rolling out new hotfixes, every other week. But at the same time, when you need to do it, ensuring that the safety invariants are still upheld and that you haven't, screwed up your safety case should also be an easier effort. So I think the future for us in cars is bright. I can't remember any other time in my career where you can make this small shift and you get higher quality, lower maintenance, lower cost in general, fewer bugs, happier developers. Like what's not to like? So yeah, with that, I thank you very much.